this presentation, we're going to tackle the question, how exactly is it that we see? So let's spend a moment with this question. It seems like something that might be answered by common sense, right? I mean, virtually everyone sees. But here's the thing about common sense. All too often, it gives us an explanation for something that's actually wrong and actually has to be unlearned. Such is our intuitive common sense understanding of how we see or vision. So, possibly the most common way to understand something is in terms of the other things that we understand, right? So consider the question again, how do we see? What I'm really asking is, how in the world does information about that thing over there get over here, where I can sense it and I can perceive it? Well, if I think about my sense of touch, I reach out and I touch it with my body. I feel it. That's how I experience that. So if I extrapolate or build on that understanding, we get one of the most persistent misunderstandings in science. And I like to call it laser eyes. And we actually see this all over the place. The heat vision of Superman, for example. And this is not a new idea. It's very, very old, and it shows up across all cultures and all eras. It's an idea that's very, very near and dear to our hearts. If you don't believe me, go to a website called www.babieswithlasereyes.tumblr.com, and you can see just how popular this idea of laser eyes is. But like I said, it's not a new idea. It's actually a very, very old idea. It's ancient. In the Hindu texts, Shiva opens his super third eye to super incinerate his enemies to ashes. The ancient Celtic cyclops Balor uses the power of the sun to destroy entire armies with his single eye. And back then, this wasn't such a fantastical idea. It made some kind of sense to people because back then we had an understanding of vision that is now known as the extramission theory of vision, which is the idea that the way we see is much like the way we touch and feel things. Because remember, we're inclined to understand things in terms of the things that we already understand. So this theory of extramission asserts that the way we see is to literally shoot energy bolts out of our eyes, what they once called fire, that would reach out and touch the world so that we could perceive what was out there. The ancient Greeks believed this, and they had some pretty good answers to the logical questions that you might arise when you're thinking about this. So it's not like they didn't think about it, right? They confronted things like, where's the evidence? So they'd look at an animal, like this deer here, and they'd notice the reflection and say something like, hey, I can see the fire in their eyes. So there you go. There's fire emanating from our eyes. And that's how you see evidence. And then there might be the question, well, how come when we're gazing into our lover's eyes, we don't engulf her face in fire, since we are in fact shooting fire out of our eyes after all? Well, Plato said because it's a gentle fire. That's what he said, a gentle fire that caresses the world. Okay, that makes sense. But there were skeptics who said, they asked the obvious question. Well, if we are shooting fire out of our eyes, why can't we see at night? Ha! Gotcha. Nope. They had an answer for this also. And their answer was that there needed to be a second fire, like a campfire or the fire of the sun. Keep in mind the understanding of light at this time was super limited, and light and fire were pretty much thought of as the same thing. Anyhow, they said fire from our eyes had to mingle with or touch this second fire, and together they would coalesce into what we see. And people said, okay, that makes sense. Very, very learned people, Ptolemy, Galen, Euclid, they all agreed that this made sense. They were the originators of our modern Western civilization, and they all agreed that the way we see was basically by having our own built-in headlights. And this persisted until about 1011, when Al-Hazim from the Arab world started inquiring into the nature of light, and he started asking questions about color and reflection and refraction, all the things we're going to cover in this course. And based on what he was seeing and the way that he thought about it, he concluded that this extra mission theory of vision, it just couldn't possibly be how it worked. It's really a fascinating story. He was able to start thinking like a scientist and challenging the understandings of his peers and teachers because he wasn't limited by a cultural rule that dictated that he not rock the boat of current understanding, so to speak. So in the Western world, there was a very strong culture of maintaining our understandings as they were, and there was not a lot of support for breaking down misunderstandings or seeing things as misunderstandings. In the Arab world, on the contrary, there was a lot of support for that. It's a very fascinating story, and we don't really have time to go into the depth that we could with that, but I've added a link to the whole story in the supplemental resources section of this module for you to check out if you're interested in learning more about Alhazen and the origin of modern optics. It's really fascinating. But the point is, he laid the groundwork for unlearning the common sense that supported the extra mission, or wrong, theory of vision for hundreds of years. And this theory of extra mission is actually incredibly persistent. It's grounded in a very, very strong sense of intuition. And the reason that you can understand that extra mission or laser eye theories is not how it works is because you unlearned it. So think about what Piaget's famous cognitive psychologist tells us about the development of kids. When they're younger than a certain age, say 5 or 7 years old, they're not very good at what's called conservation. And the best example of this is how when you pour water from a short cup into a tall cup and ask them, was there more water in the short cup or is there more water in the tall cup, they'll actually tell you that there's less water in the tall cup. Even though they saw you take the same amount of water and pour it into the tall cup, they have this very strong intuition that there's less water in the tall cup because it looks like there's more empty space in the tall cup. And until they're of a certain age and their brain has developed to a certain extent, they really have a hard time cognitively getting over this intuition. And the same is true for kids of this age regarding vision. Typically, they'll tell you that the way they see is by shooting something out of their eyes. But Piaget didn't do any research into this. It wasn't until about 1996 when Jane Cottrell and Gerald Weiner did some research. They did a pretty extensive body of research, compiling more than 20 studies and several different methodologies. And what they found is that, in fact, 70% of third graders and 51% of fifth graders do, in fact, describe vision in terms of the extra mission theory. They'll tell you something comes out of our eyes and it goes out to the object, and that's how we sense it. But what really blew their minds in these studies is how persistent this belief is. Among college freshmen, 1/3 of them still described vision in terms of extra mission. So this is what we're up against when we're dealing with young children and teaching them about light. It's a very strong intuitive sense that's very challenging to overcome. And we're going to close this presentation with that. The next presentation introduces our first activity. It's called the Classroom Cave, and it covers a lot of ground and is intended to really ground beginning students in experience that challenges this intuitive understanding of light. And for this reason, it makes a really great introductory activity for almost any group of students who are going to study about light, even those you think might already get it. So I'll see you in the next presentation. Thanks.